Hi, good morning, and welcome to the ZP webinar for FoodSense Generation 4. So we like to do this webinar once a week, and it's just answering technical questions that come in during the week. And so today we're going to do a deep dive into something called oleoresins. Do have in front of me actually a FoodSense Generation 4. So FoodSense Generation 4 is for measuring the Scoville Heat Unit of natural chili products. I shouldn't just say natural. We can deal with chilies themselves. They have to be chopped up and extracted. We can also deal with chili sauces, chili powders, oleoresins, chili flakes, and then sort of very heterogeneous products. I don't want to say chili beef, but things like breaded chicken and things like that. And honey, mayo, all sorts of complicated chili type products. With that said, let me go back to my main screen. Now, what we're doing at ZP FoodSense Generation 4 is we do personal online training. So if somebody's a client, and so just of recent, we did some training online for a team in China, and we just did a training for a team in South Korea. So we definitely do personal online training. We do weekly webinars. This is one of those weekly webinars. Today, I'm going to specifically talk about oleoresins. So I don't know if I'll tell you what oleoresins are. If you take chilies and you sort of chop them up and you dehydrate them, and then you extract all the capsaicin out of those chilies using organic solvents, then that's a very efficient way of getting the capsaicin out of the chili. But then you've got this capsaicin in organic material. So what they then do is they then distill off all the organic solvent, and you're left with this black tar. Now that black tar is very concentrated in capsaicin. So when somebody says an oleoresin is kind of more generic, but in the case of chilies, you've got a source of capsaicin. It could be a chili, it could be a chili powder. You've extracted all the capsaicin into the organic solvent. You've then distilled off the organic solvent, and you're just left with very non-volatile oils that are very rich, very rich in the capsaicin. And this is a kind of black tarry material that it's got a high viscosity associated with it. So we do weekly webinars, and this week we will talk about testing oleoresins, and we also do monthly webinars. So if you're interested in seeing the FoodSense Generation 4 actually testing things like chilies, then you are very welcome, because we do these monthly webinars where people can come in, see us do a couple of webinars, and so that's something that we do hold on a regular occurrence. With that said, let me go back to the slides. So we do those monthly webinars. The next monthly webinar, in fact, is on the 1st of August, but if you click the link, you will find that every time we have a new webinar booked, the link will have been already refreshed. So just keep on clicking this link, even if you're watching this in 2025 or 2026. Keep on clicking that link, because you will find that we'll have updated with the next, let's say, webinar in the series. The question today is about testing oleoresins. This is quite an interesting, let's say, question, and I'll sort of dig into it now. So first of all, the preparation. So at Zimmer & Peacock, we do give people personal online training. It's a very simple little unit to use. In fact, there's lots of demonstration videos online regarding how to use this. Some that actually involve children, and I think it's really fair to say that it's literally child's play to actually use the instrument. But I do want to dig in a little bit today on some actual data. Right, so now this, it's probably worth saying that every time a customer has a problem, we can train them, or if they're really having problems, we try to understand what the cause of the problem is, and we do SOPs for them. These are called kind of standard operating procedures, where we'll actually take a similar material, take the same material, go into our lab, and work out a protocol for them. But we'll only do this for actual customers. I think there's two parts to a product. There's the product itself, and there's the customer support itself. And so our customer support, when it comes to testing, I think is really good. And I think part of that really is is also linked to the data that I'm going to show on oleoresins today. Actually comes from Indonesia. So in Indonesia, we do have a really excellent team there called PT Mab, run by a couple of very good entrepreneurs, and they have a very good technical person there as well. So now I'm going to put a halt on everything else I was talking about, and I'm going to specifically now talk about oleoresins. So with the oleoresins, the team in Indonesia, PT Mab, they do understand that capsaicin, the maximum solubility of capsaicin is in buffers. And buffer, I mean, this is a buffer here now. In a buffer, this is just this kind of liquid, is about 500 Scoville heat units. Now, when you've got oleoresins, they're naturally high in capsaicin, so they actually have quite high Scoville heat unit rating because you've condensed all of the organic molecule into a kind of a small volume. So it does suggest that we need to do quite high dilution on those oleoresins, and you'll see today that when they're testing oleoresins, and you'll see results today of about 3 million and 2.5 million Scoville heat units, that is, they are really they're really doing high dilution. So dilution will come up today. They use a buffer, so if you have a FoodSense Generation 4, it comes with 500 milliliters of buffer. They do use a vortexer quite a bit. In fact, I've got a vortexer in front of me. Vortexers are good. They're not super expensive. You can get a vortexer off. You know, it's easy for us in Europe and the USA, but you can get these devices off Amazon. This is a vortexer, and it basically just shakes really fast. If I take this kind of chili sample and I put it on there, it just vibrates very fast, and it's a very good way of extraction. So when you're dealing with something like an oleoresin, you've got all this capsaicin in this tar, and you essentially want to get it, tar is a good term for it. You want to get it out of that, and so the extraction is probably best done on something like a vortexer. They very much understand as well at PT Mab that the final solution we test is 50 microliters, and they also understand that what's really clever about the FoodSense Generation 4 is you'll get a nice simple answer on your phone. So you'll get the results. If it's very high in concentration, you need to dilute some more. The app is smart, and the app will tell you need to dilute this because it's a hot sample. There's a lot of capsaicin in this, and you need to dilute a bit more. So it does have an AI capability of looking at the data and advising you, and that's what it does. Now, the reason I bring this up is because it's not only showing your result on the phone, it's actually storing the result, is storing the user, the time, the date, the raw signal, and I think I said the result, all in the cloud. So in fact, you have a really good traceability on this as well. So it's a pretty clever little device. Now here we're going to test 6 samples. Now they've gone through this in a very kind of systematic way, doing increasing dilutions. But they do understand at PT Mab, and this is PT Mab's data, that the maximum solubility, or the let's say the rule that we follow is that capsaicin has a solubility in water/aqueous solutions of about 500 Scoville heat units. So if you want to test something that's like an oleoresin, which maybe is 1.5 million, you can appreciate how much dilution you actually have to do. So they did 1 in 10. Now, when you look at 1 in 10, that means that theoretically, if this oleoresin is thought to be 1.5 million, then 1 in 10 would give you 150,000 Scoville heat units. And what you see is that they actually end up recording results of 56,000, 56,000, 56,000, 56,000, 57,000, if I round up, 56,000. They're very, very repeatable. Now, what's happened here is that, in fact, the solution is saturated with capsaicin, and so in fact, you get the same result because what you're measuring is a saturated solution. But there's in fact more capsaicin in the sample; it just didn't dissolve. So then they do the next bit where they actually do a 1 in 100 dilution, and you'll see the results here. It's like 575,000, 560,000, 574,000, 567,000, 574,000, 569,000. very, very repeatable results. But again, they're measuring a saturated solution. So there's still some more capsaicin to be measured. By the way, the app will definitely have told them this, because the app is able to look at the data. It can see the intensity of the signal, and it will have advised them, no, you need to dilute it some more. So they did 1 in 1,000, and then they came to the 1 in 10,000. Now, when they did 1 in 10,000, that means if you if you think that maybe it's an oleoresin, you think it's quite strong, and you think maybe it's 1.5 million Scoville heat units. 1 million divided by 1.5 million divided by 10,000 is 150 Scoville heat units. Great. Now, when we measured it, we actually recorded an average, and they did a lot of repeats here. They did something like 6 repeats, maybe. Yep, 6 repeats, and they've got an average of 3.74 million Scoville heat units. Now, before you go, whoa, that's wrong, I want you to see sample 2, and I think sample 3. You're going to see a trend, and you're also going to see some ones where actually we get it exactly on. Because what I want to say is, when you look at somebody says, you say, what is the hotness of your oleoresin? And they say 1.5 million. That's a very round number. So what I mean by that is, when you're measuring something that's a natural product, you are never going to get something that is 1.5 million Scoville heat units. It's just too rounded. So I suspect that this is not really come from any kind of analytical method. This may come from a data sheet by a supplier, but I do not believe that this expectation of 1.5 million, very round number, no other numbers in that 1.5 million, not 1.5, not 1,555,000, not 1,495,000, but 1,500,000, too round a number. So when we measure it, we get 3.74 million. But we've also tested it at least 6 times, and we get a relative standard deviation of 8%. So it's not an error by us. We keep on measuring it, and we keep on getting about 3.74 million with the spread in data of 8%, which is very acceptable for a natural product. But listen to the story now, because now we've got oleoresin number 1. They think it's 1.5 million. They've got oleoresin number 2, which they think is 1 million. So there's going to be a sequence of events here. PT Mab, really good. They're very good in the lab with their repeatability. They do a 1 in 10 dilution. It's too dilute, but they get this 57,000 Scoville heat units. It's very similar to what they were getting when they did a 1 in 10 dilution on that 1.5 million. Why is it so similar? Because in fact they are accurately measuring and precisely measuring the capsaicin that is diluted. It's a saturated solution because it's only 1 in 10. Then they do the 1 in 100, and they get about 577,000. That's very similar to what they were getting for sample 1. Why? Because again, they're dealing with saturated solution. They do their 1 in 1,000. They do their 1 in 10,000. So the 1 in 10,000 is the one that is the correct, let's say, dilution. But notice here that in fact they do about 6 tests, and they get 2.5 million Scoville heat units. Now, it's less than sample 1, but it's higher than expectations. But sample 1, they think it was 1.5 million. I think we measured it at about 3.2 million. Sample 2, they think it's 1 million. We measure it at 2.5 million. And you could say, all right, well, in that case, the FoodSense Generation 4 is wrong. But they've done it 6 times, the measurement. They've got a relative standard deviation, or a spread in the data, of about 12%, which is low. And sample 1 was meant to be the hottest, and sample 2 is slightly milder. So I say hottest, the customer had the expectation it's 1.5 million. On sample 2, the customer has the expectation it's 1 million. 1 million is again a really neat rounded number. I don't believe this is actually based on a recent analytical method. It's 1 million. Nothing can be just 1 million like that. But FoodSense has also got the right order, that sample 1 is hotter than sample 2. Their expectation is that sample 1 is hotter than sample 2, and the FoodSense has done that. It's just the absolute numbers. They expect 1.5, we record it about 3.2. They expect 1, we record it at 2.5. But the order is correct. But before you say it's the FoodSense Generation 4 that's in error, let's have a look at sample 3, where sample 3, they say it's 1 million. Again, it's too round a number. Again, PT Mab understand the rule, so they understand you can't do 1 in 10, you can't do 1 in 100, you have to do 1 in 10,000. If we look at the PT Mab's 1 in 10,000, now this time the customer thinks it's a million. And in fact, we record it at 1 million. So with their sample 1, we were very precise, but we were different from their expectation. With sample 2, we were very precise, but different from their expectation. Sample 3 is meant to be pretty similar to sample 2 because they expect that to be 1 million. We do record it. We recorded it something like, PT Mab, about 6 times. They get 950,000 Scoville Heat Units. So they're basically within 5% of the customer's expectations. So the customer's expectation on the sample 3 is actually correct. And it's sample 1 and sample 2 where the customer's expectation is not correct. Because otherwise we would be very fortunate on sample 3 to get so close to the customer's expectation. But when you see our measurements, look at our measurements. We recorded it at 1,038,000, 941,000, 934,000, 943,000, 970,000, 932,000. Those are real numbers. When somebody says my Scoville Heat Unit is 1 million, that's not a real number. It's when you get 941,600. Those are, let's say, the real numbers. So I just want, we did it also 6 times. So on sample 3, absolutely in line with the, let's say, customer's expectations. Sample 4 is further evidence of this. So in sample 4, now this time they think that it's 500,000 Scoville Heat Units. And in fact, when we test the sample, we get an average of 490,000 Scoville Heat Units. So you can see with sample 3 and sample 4, and a very good precision as well of 11%. With sample 3 and sample 4, absolutely meeting the customer's expectations. And 1 and 2, we're in the same order as the customer's expectations. It's just that the customer thinks the sample 1 is 1.5 million. It's hotter than that. And sample 2, they think it's 1 million, but in fact it's hotter than that. It's 2.5 million. And we do come across this quite a bit, especially when people have very clean numbers. The customer's expectations so far have been 1.5 million, 1 million, 500,000. This is not the way that natural products actually really work. But sample 4, we're very close to their expectations. Sample 5, they're expecting, again, a very clean 500,000. And in fact, when PT Mab do it, they get 583,000, which is, again, very close to the customer's expectations and a very good relative standard deviation repeatability. Just lastly, I think they've made up there's a compound out there called non-vamidide. So what they're doing here is when you look at most natural products, so in capsaicin, most of the hotness comes from, when you look at a chili, most of the hotness comes from capsaicin. This is a structurally a very similar molecule, and it's also hot. So they've made up some solutions, and they don't have an expectation on the Scoville Heat Unit. You could test a theoretical. You could theoretically calculate this based on the known concentration that they diluted. But in fact, we did record this unknown solution to us at about 618,000 Scoville Heat Units with a good repeatability. The one thing I'd say about FoodSense Generation 4 is when people have HPLC only testing, they have no way of doing repeatability. So in fact, you never see people talking about the relative standard deviation of test when they're talking about HPLC, because it's too expensive and too slow to actually do that kind of testing. Because the cost and speed of FoodSense Generation 4 means that actually people could do a lot more retesting. They get a much better statistical understanding of samples. So for example, you see these chilies here? Each one of these chilies is going to have a different Scoville Heat Unit rating. It's a natural product. They're very heterogeneous. And that heterogeneity is really lost on, I think, on a lot of the industry. Because in fact, they can only afford to, for example, ever do one particular test. And that particular one particular test may actually be biased because that was the sample you took. Whereas 90% of the rest of the sample isn't exactly the same as that small sample that you actually took. So the thing about FoodSense Generation 4, because of its speed and cost of test, people can end up doing a lot more tests and getting a lot better statistical data on this. So if you want to see the FoodSense Generation 4 in action, the next live streaming webinar is on the 1st of August. We do one in the morning, it covers places like Indonesia, and we do one in the afternoon, and that will cover places like South America. So we do 2 webinars on the day. If you've got any questions about FoodSense Generation 4 and the testing of oleoresins, I would basically say, please don't hesitate to reach out to us. Okay, thanks very much.